last time we talked about how to find asymptotes, vertical, horizontal, oblique asymptotes when you had a graph, and this time we're talking about how to do it when you have an equation like so. Now, I don't know if you remember, I'll go back to that slide in a second, but last time when we had the graphs, your domain always matched up with your vertical asymptotes in your holes. And that's because, so if you think about fractions, domain are always in the denominator. That's how you find vertical asymptotes in holes. So you always factor numerator and denominator. You get rid of common factors. Anytime you have a common factor, that's when you have a hole. And then the vertical asymptote is everything else left over in the denominator after you take out the common factors. Whatever those zeros are, that's going to tell you your vertical asymptote. Now, there's like a fancy chart they often show with finding horizontal or oblique asymptotes, and this is the chart where it's either y equals 0, y equals a over b, or an oblique. Literally all you're doing is you're doing division. You're using long or synthetic division to figure out what the horizontal or oblique asymptote. Because a horizontal oblique asymptote is literally you're just figuring out what line you're approaching, getting really close to. So you're doing the long or synthetic division, but taking out the remainder. So I'm actually going to show you, so you don't really have to memorize this chart. I'm going to show you how you can find the horizontal oblique asymptote without needing to know a chart. So it doesn't matter what order you find these in. I like to find the vertical asymptotes in holes first. And let's just go ahead and do that. So first thing I do is I factor. And I factor everything. So we have 2 and then x plus 2. And then we get x plus 2, x minus 2. Now, in this one, we have a common factor. We get rid of that. So we have 2 over x minus 2. So here's how it goes. Whole is based off of that common factor. Oops. Every time I think I get the highlighter, I don't. So here's our whole. That's based off our common factor. And you do the 0. So it's negative 2. I'll show you how to find the y value in a second. Vertical asymptote, remember, is just matches up with the domain. Well, both of these match up with the domain, but the vertical asymptote does not include common factors. So the vertical asymptote is at x equals 2, because the domain would be x can't be 2 or negative 2 in this case. Now, to find the y value of the whole, a lot of people try to do the same thing every time. They'll plug it into the original, because that's usually how you find a y value. And then they'll get confused and they'll say, oh, 0 over 0, so our answer is 0. No. That's not how you do it. Okay? So please don't ever do that. The 0 over 0, anytime you plug something in and you get 0 over 0, that tells you that you did get the whole. You found the right x value of the whole. But you never plug into the original. You plug it into the simplified version. Because otherwise you're always going to get 0 over 0. That's the whole point. Because you're getting a common 0 on top and bottom. So 2 over negative 4 is negative 1/2. And that will be the y value of the whole. And there it is for those. I should have given myself more room. Sorry, guys. So then we got to do a horizontal or oblique. So I shouldn't have boxed that. I'll leave some space. Horizontal asymptote or oblique asymptote. So really what you're doing is long division or synthetic division. So like for instance on this one, you can use this form right here. You could use the original. But if you look at this, if I used the original, I'd have x squared minus 4 and then 2x plus 4. The problem is you're already at the remainder. So this 2x or x squared goes into 2x 0 times, right? Same with this one. If I use synthetic on it, so I put a 2, and you only have 2, you drop that down, boom, that's your remainder. When it comes to finding horizontal oblique asymptote, you always ignore the remainder. Okay, so what's your answer if there's nothing but a remainder? Well, here it is. It's literally just y equals 0. And that's what this chart is saying. If your numerator's degree is smaller than your denominator's degree, that means you're already at your remainder, so your answer is just automatically y equals 0. Okay, so we'll do the next one. Once again, first thing I do is factor. So I'll get x plus 1, x minus 1 on the numerator, and then 2x plus 3 and x plus 2 on the denominator. So there are no common factors, so wholes, there are none. And you can have multiple wholes, by the way. You can also have none. You can also have multiple vertical asymptotes. So the vertical asymptote are going to be the zeros of both of those. So we get x equals negative 3 over 2 for the first one, and negative 2 for the second one. Remember, if you're stuck and it's hard to figure out what the 0 is, I'll write it up here. If I take that 2x plus 3 instead of equal to 0, then you just solve. So you subtract, divide by 2. Subtract 3, then divide by 2. All right, horizontal or oblique asymptote. I usually just group them. It doesn't really matter because you'll know if it's oblique if it's in the form y equals mx plus b, and so on. Now this is one where I'm going to have to do long division. So I'll have 2x squared plus 7x plus 6 over, and then the x squared minus 1 would go inside. Now I can divide these because they're the exact same exponent. So 2x squared divided by x squared is 2. Now I'm already at my constant, so, I can't even, is 1/2. Try that again. I said it wrong, I think. So let me just fix what I said. You're doing x squared divided by 2x squared. And that will give you 1/2. And at this point, since we're already at the constant, I can go ahead and say this is my answer, because remember, remainder does not matter. So I don't know, a quick trick on those ones, if you don't want to have to do the full long division or whatever, just look at the first terms and they'll tell you exactly if you're going to have to continue long division or not. So on this first one, if I divide those, you automatically have it's automatically at the remainder, so your answer is 0. If you divide x squared by 2x squared, you get the 1/2, so you get your answer right away, and so on. I'll show you that a little bit more soon. So let's do another. Let's do this next one. The numerator does not factor and the denominator does not either, so that makes life pretty easy for us. So we're going to go ahead and say there are no wholes. Vertical asymptote is going to be at x equals 2, because remember, you look at the denominator. So there's your vertical asymptote. And then horizontal or oblique. So remember that quick trick I just mentioned. You're taking the first terms. In this case, if you take the first terms, 2x squared divided by x is 2x. That tells us automatically it's going to be oblique, and we do have to keep going. So we're going to have to do our synthetic division or long division, depending. So I'll do 2. I have 2, 0, and 3. Now the reason we have to do this is because we've got to find our y-intercept. We know the slope. It's 2. 2 times 2 is 4. 2 times 2 is, or 2 times 4 is 8, 11. So remember, we always ignore the remainder because it's what we're approaching. So I really only needed to get up to this 4 to figure out what my y-intercept would be for my oblique asymptote, and there would be my answer. Okay, so I showed it kind of a little more complicated on this first one where you actually divided, but there are quick tricks so you don't have to actually do the longer synthetic division most of the time. So let's see that on this next one. Let's actually start with horizontal asymptote or oblique asymptote. So same idea. I look at just the first terms, and if they're in standard form, it does have to be in standard form. If I divide those, the x cubes cancel. So you get y equals 5 over 2. So we're already at a constant. Therefore, you don't need to keep going. So I've already found my horizontal or oblique asymptote. So let's find holes and vertical asymptote. So I'll factor, I'm going to put it down here. So we've got y equals 5x cubed over 2 times x cubed minus 8. And then we'll factor that. That's the difference of perfect cubes. So that's that one formula that we all love and cherish. So that one right there. So I'd have x squared plus 2x plus 4. So there are no holes, once again, because there are no common factors. Vertical asymptote. Now it's going to look like there are 3 because it's to the 3rd power. We only keep real vertical asymptotes, so real answers. So I'm actually only going to have 1. And the reason being, if I try plugging this in and I have to use the quadratic formula, you get negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 4, all over 2 times 1. Well, if I go ahead and plug this in, I get a negative number under the square root. Therefore, this will be imaginary, and we only keep the real numbers. So skip imaginary. You do not include those.